Go. Got my big screen over here. Any questions from last week? Or I should say earlier this week, Tuesday? Well, that's
Not
right.
from me.
Go ahead.
I said not from me. I don't have any.
Oh, no questions. Okay. That's great. So what did we cover last Tuesday? What fun did we have on Tuesday? Anybody happen to remember?
Spanning tree.
Yeah, we did spanning tree. Okay, so a quick review. If there were three steps that you wanted to remember for spanning tree, the three steps that the algorithm goes through. Anybody happen to remember what those three are? Offhand? How about what's the first step in spanning tree? What's the first thing that spanning tree wants to do? Anybody happen to remember? Okay. Elect a king, right? No, that's not it. Somewhere else. Determine the root bridge. Okay. Does everybody remember how the root bridge was determined? Anybody have any question on that? I mean, just, I don't want to go over if everybody's all up on it, but everybody's good with that. All right. Well, we'll go on to, let's see, module 6. There we go. And then back here. Share my screen. Okay, I'm going to go to the top of this. So this evening, we're going to start by looking at ether channel. And ether channel is, simple in concept. It is, can be a bit involved, but actually configuration is also quite simple once you work with it a little bit and understand what's going on. So there is really the situation that gave rise to ether channel is spanning tree. So what would happen is, and let's just go down to this right here, next slide. Can you folks are seeing my slides okay, correct?
Yeah.
Okay. So we'll have two switches, and if we add a second link between the two switches, and we don't have ether channel, what happens? Spanning tree is going to block one of those 4 ports. So if we add another link, because spanning tree fooled us, what's going to happen? Spanning tree is going to block one of those ports as well. And just keep as many as you add in there, spanning tree keeps blocking a port. So that when you get done, if you have, 4 links that you've added between these two switches, 3 of them are blocked, and spanning tree only allows 1 link between the two to be used. Well, that's not very efficient. If you want to increase your bandwidth by adding links, and you don't want to just go buy a faster device. Obviously, if you went and bought faster devices, then on each end, you connect a cable that's running something like gigabit or 10 gigabit. But when you want to increase the speed, that's an expensive option. So they came up with ether channel. And what ether channel does, it's going to provide a number of advantages. One, it's going to group the links into one single logical link. So that way you don't have spanning tree closing down one of the multiple links that you have between the two devices. Now, how does that work? Well, because each end knows that the ether channel is a bundle. If a broadcast comes in on one of the links in the channel or in the bundle, that broadcast is not sent out over the other links in the bundle. Therefore, you will not get a broadcast storm. So that's your first advantage to having ether channel, is that you get increased bandwidth by simply adding links into the channel, into the bundle. The second advantage is fault tolerance. So as you have multiple links between the two devices and they are operating in a bundle, if one of those links in the bundle goes down, the rest of the links remain active, the bundle remains active, and whatever the bundle was being used for, it will continue to be used in that way. So if it was used for a trunk, it'll keep being a trunk. If it was used as a single VLAN link, or if it was used as a layer 3 link, any of those are fine. So you provide fault tolerance. The other thing that you get to some degree is load balancing. Now, what they say in the slides is you get load balancing, but actually what you get is load distribution. And we don't need to know in detail how that works, but let's just say you had, 4 links in a bundle. What the end device would do is it would say over link 1, we'll have all those MAC addresses that end in A, for example, and over link 2, all those that end in B, over link C, all that, or 3, all those that end in C, link 4, all those that end in D. Okay, so, and this is a, oversimplified explanation or analogy, but it is effectively what's happening. So let's say you've got now these 4 links, one's carrying A, another B, another C, another D. Well, if all you get was A traffic, then the other 3 links are idle. Whereas if you had load balancing, true load balancing, what would happen is that the A traffic would be distributed over the 4 links, but that's not what happens. But because not all traffic ends up being, categorized into just, one of these 4 operations or 4 labels, you end up having traffic being sent over multiple links or distributed over multiple links. So technically what you have is load distribution. And that becomes relevant to an administrator if, for example, you have a endpoint device that people are communicating to. Let's say people are going to a server, and where they're coming from at the other end is some device that is a single device. Now you would have the possibility that all traffic would go over one of the links, because you'd have all traffic initiating from a router with a MAC address that would be set, and all traffic initiating from the server with a MAC address that's set. And so basically you would end up overutilizing one of the links. But usually that's not a situation that you have to be concerned about, especially in the way that we use these channels, these bundles, to support trunks in between switches. So essentially with ether channel, we're bundling these multiple links into a single virtual link. And then what we do is we configure the virtual link. It's called a port channel. And we configure the port channel on each end to have whatever capability we want to have over that virtual link. So it's an interface that's called a port channel. So here we see the different advantages that I was referring to. These restrictions here you want to know as well, because these will be things, first of all, from a configuration standpoint, you need to know this so that you don't misconfigure. But usually, when you're configuring Ether channel, you'll probably already have these restrictions met. You'll probably be using the same speed interface on each end. You'll configure them to be the same on each end as far as duplex and so forth. However, you want to know these for the test. Okay. These are great things to test people on. So all these things have to be met. Essentially, they're all criteria that has to be met before you can form a bundle on each end. There's two protocols. Couldn't make it just one, we have to make it two. We have the port aggregation protocol and the link aggregation control protocol. These basically work the same, but they are not generally intercompatible. So you use one or the other to control the configuration and actually management of your bundle and your link. So PADG-P, as they're referring to it here, Cisco proprietary. And what it's going to do is bundle these ports for you and make a port channel. And as we see here, there's a sort of a summary. You have to have the same speed, duplex setting, etc. Once PADG-P has formed a channel, an Ether channel, then it will continue to manage that link. And if there are any failures, it will take care of any failures that occur on one of the lines in that bundle, or the links in the bundle. You want to know this too, and we'll see a slide here in just a little bit, the next slide, that you'll want to make sure you understand. So if I was an administrator, I wouldn't worry about these two down here. I would say, if I want to form with PADG-P an Ether channel, then I would use on each end. And this is just like it was in trunking, and very similar options as you had in trunking. What I would do as an administrator, if I want there to be a trunk, I turn trunking on both ends. I don't leave it in auto or desirable, because those two get a little trickier, can be a little less predictable, and well, that would lead to a misconfiguration. So you just want to turn it on each end. But for test purposes, you need to know what these are and how they work. Desirable, active negotiating, auto passive negotiating, which is a little counterintuitive, because you'd think if something was going to automatically form a channel, that it would be active in its negotiation, but it actually is not. So here's what you'd want to remember for the exam for PADG-P. So just take a little mental picture of that. Okay, I know these things get all these different little graphics here, and keeping them straight becomes the problem. But as I said, on and on means that you have a channel, desirable and desirable channel, desirable and auto channel. Auto and auto, no. The other protocol that you have available is LACP, Link Aggregation Control Protocol. And this essentially is the same as PA or PADG-P. The difference being that this is not Cisco proprietary. But we have these different modes here: on, active, and passive, and essentially corresponding to the same states there with HAJ-P. So again, coming down to this diagram here, you would want to memorize that for test taking purposes, and then forget that about a minute later after you take the test. You can forget that because when you go to configure this, it'll be some time down the road, and at that point you will look it up and figure out what you need to do. But your basic thing is on, and on means that you have a channel. So now we'll look at configuring ether channel. So again, some guidelines and restrictions here. We have to have interfaces that support ether channel. But let me get this down here. They do not have to be physically contiguous, so they don't have to be next to each other. But for purposes of administration and sort of, keeping things sane, you'll probably want to have the ether channels physically contiguous. Speed and duplex modes and parameters must match. Your VLAN on each end must match, or if you're going to make it a trunk, the range of VLANs must match. So those are things that you would hope, actually, because if they didn't require that, then you could set up ether channel operations that resulted in really strange behavior. It'd be hard to figure out what was going on. Better to have the ether channel fail and figure that out than to have it form and then not behave properly. Okay, so once it's formed, we see here we've got matching configurations, and it can be configured as an access link, a trunk link, or a routed port. And trunk, as they say here, is the most common. Usually what you're trying to achieve with this is what they would call uplink, or uplink capability and speed increase. Very, very easy to configure. You simply go into the global config mode, and you then go to the interfaces that you want to configure. And probably the easiest way to do it is go interface range. And in this case, fast Ethernet 01-2. In packet tracer, I think we have to use the FA in front of each one. We'll see. That's what I found. Then channel group 1 mode active. So channel group 1 puts all of these interfaces into an Ethernet channel numbered 1, and its mode is active. Okay, so that's simply saying that we're going to go ahead and try and configure or build an ether channel configuration for LACP. Then you exit out. You now have created a port channel, and you exit out, go into the interface port channel. And in this case, we're going switch port mode trunk, and then switch port trunk allowed VLAN, and simply saying only those VLANs can cross. Now, it's recommended for security purposes that you limit to a trunk only those VLANs that you want to cross that trunk. By default, in Cisco, a trunk allows all VLANs. by default in Juniper, it's just the opposite. By default in Juniper, no VLANs are allowed. So you have to actually specify which VLANs go over the trunk. That is probably the preferred or more secure method. But what you can get is the same result here. Just simply say which VLANs are allowed over that trunk. And we have a lot of commands here: show interfaces, port channel, Ethernet channel summary, Ether channel, port channel, interfaces, Ether channel, etc. And some issues that we might come up with. Again, it would be a matter of some type of misconfiguration. Okay. Okay, so we've got FA01, 1, 2, 2 connected with Ether channel. It's not operational. Let's look here. Show Ether channel summary. And we're looking at what's happening here. Shows that it's down. Ether channel is down. And then if we do a show run, we're looking at the actual configuration. Okay. And we have VLANs that are allowed. And we're looking at the S1 versus S2. And we're trying to see if we find some discrepancy between the two. And we see that we've got these channel group mode on, and this is desirable and desirable. And these modes, they're indicated here, are not compatible. And so we're going switch port mode trunk, and that is going to hopefully fix that. And then when we show it up, it's up and up. Again, show summary. So now what I've sent out to you folks is a scenario, and I have that here. Okay, and what I'm going to do is I need to highlight that, and we're going to go through this process here. There we go. And you might want to pull up your scenario. It should look like this when you pull it up. And then we can go to switch 1. And the channel is now down because I just wiped out one of the links there. Do a show run. I'm going to still have some commands in here possibly. I do. So I'm going to escape that. Go config T, no interface, port channel 1. Up. That was 1. Yeah, port channel 1. And then do a control Z, show run. And let's see if we have. What I've got is, okay, 4 and 5 are both configured as trunks and now shut down. So let's do this. Let's make them, let's see, interface range 0/4. Now in the slide, it said you could just do that. Let's see if that did work. Okay. You have to, for some reason I had a problem earlier with that syntax. And no switch port mode trunk. Okay. and do a show run and see if that. Okay, so those are interfaces are shut down. And we'll go back there since it's going to be easy to do. A no shut. Okay. All right. I'm going to bring this side up as well. Imagine where you are, it's raining as well. I came up to Northern California and what's going on with all this rain?
Yeah, it keeps on coming and going.
Yeah,
It's annoying.
Started about an hour ago
yeah.
in San Jose.
Yeah, I came through San Jose earlier today and there was snow on the eastern foothills, something you very seldom see. There are the mountains that are behind East San Jose. Pretty interesting. Okay, so I'm going to clean this one up as well. Okay. Then and where
Do
we
you
go.
make that dotted line connection between,
What's that?
how do you create that dotted line connection? Which-
.09?
That dotted line connection.
Oh, okay, just a second. Yeah, I'll do that next. I'll show you here. No.
Because I like to do these things from scratch, and it took me a while to connect things once, and I had to go on YouTube, and it said, well, you have to install this onto the switch first. I went, okay.
Yes, so
I figured it
here's
out.
what you do. You go to this right there and you go there. And you go there. And I'm going to put this for FA05 on each side. Okay. Now these are shut down on each side, but now I can go in and I have something to bundle. Okay. Did you see how I did that, right?
The copper crossover, okay.
No, right there. Yeah. Just connect it to each end. Now I go back to switch one. I'm going to go back to the top. So I start where I would here. I'm going to do a show run just to see if there's anything going on that would be weird. Nope, everything's at the defaults except for that one VLAN. Okay, and then do a show IP int brief. I don't think that we're going to have, let's see what we do. Okay, so 4 and 5 are down. That's fine. Okay. Right, so I'm going to go config T interface FA0 4-5 interface range. Sorry. And now what I want to do is assign those to a port channel group 1 mode, and then let's see what our options are here. So I can have it on or active. I'm going to go with on and see what happens here with this. Now, FA05 is not compatible with FA04. let's just see what's going on here. Let's do a show run. Let's see if 4, okay, so they look like they're both okay there. Let's see here. Options to this. Let's do a no shot just to make sure. I think that's a problem. Okay. Now, Control Z. Now, if we do a show run, what we should see is that the port channel was created. So we now have an interface. We didn't put that command in there. By bundling those links into channel group 1, the system automatically created the virtual interface. This is a software interface called port channel 1. Now to go to that, we go config T, interface, port channel 1. And I'm going to put this in as a trunk. And there we go. So as we see, it's still shut down. My guess would be it's because it's shut down on the other end. So we're going to go to this one now and repeat these commands. So we have 4 and 5 shut down. Okay. So let's go config T, interface FA0/4. Oh, I'm sorry, interface range. And we'll do a no shut first of all, bring them up. Okay. Now let's do channel group. Oh, there we go. Channel. Interface range channel. Channel. Let's just see what our options are there. Channel, yeah, it's dash group. I'm sorry. Dash group. 1 mode. And then we said on. Okay. So now we have that. And then what we want to do is in this, not in these interfaces, but let's just do a Control Z first of all, do a show run. And now it's interesting that it put it into a dynamic desirable. I'm not sure if that's a glitch in Packet Tracer or what, because we turned it on both ends. But we'll go here, config T. Oh, wait, I don't think we did yet. I think we just, yeah, the port channel, we haven't made it. Yeah, okay, it's desirable by default. So let's go config T, interface, port channel 1, switch port mode trunk. And now let's go show interfaces trunk. And now what we have is the port channel. The ones that we just configured are trunking and the mode is on. What VLANs are they carrying? The port channel 1 is allowing all VLANs. There's only one VLAN created, so it is creating or carrying right now VLAN 1. Okay. We wanted to test this. Let's just go go here to switch one. Let's see what we've got going on here. Do a show VLANs. Yeah, we do have a VLAN 2, but we don't have anything in it. And we have VLAN 1, but we don't have FA01, which is, I would think we would have out here. These be FA01, 2, and 3. So let's go ahead and fix this. We'd like to be able to make this whole thing work and test our link. We could ping from one side to the other. Let's just look first of all at that. Let's do a show IP int brief and see if we have port channel shows down and down. That's interesting. So here's VLAN 1. That's the virtual interface there. And we'll go show IP int brief. 2. Okay, so this shows the port channel up. The other shows the port channel down. Down and down. That's interesting. Let's just see what's going on here. I'm not trusting packet tracer all that much. Ping 172.16.1.1, and let's see if it works. No, it's not. No, it's not working. Okay. So let's go back over here and see. Port channel 1 is down and down. Well, let's see if we can figure out what's going on. Let's do a show run on this. So it's a trunk on this end. Four. Oh, okay. So we have an incompatibility right there. FA04 is in trunking mode, but FA05 is not. We should take that off. Let's see if that helps. I thought I took this off. No. Switch port. Oh, boy, it's raining a lot here. Okay, Control Z. Man. Show run again. Let's see what's going on. Okay, now there's no incompatibility, but let's do a show int trunk. Let's see what's going on. FA01, but the port channel is not working anymore. Oh, wait, now it's back up. Now, wait, okay, the links are back up. Let's put it that way. The links are up, but now let's see if we can ping across it. Ping 2.16.1.2. Okay, not working still. Okay, show port. No, let's see. Let's do show channel. Let's see. We got an option there. Show channel. Channel. Let's see what we've got. Okay, so it's not letting us look at use those commands. I'm thinking that a lot of this is a problem with packet tracer because we issued the commands, but these two switches here are not communicating. We do a, well, let's just go back to 2. Anybody see anything that I might be missing on this? That
I'm getting the same error, or I'm not able to ping.
okay. So look at this, we've got over here, switch port mode trunk, switch port mode trunk. I took that off of each one, I thought. So what I'm gonna do is go back in and see if I can take that off. Interface range. FA 0/4-5. No. Switch port mode trunk. Okay. Let's do Control Z. Show run again. See if I took it out. Well, that's okay. Channel group mode on and on. Okay. Show int trunk. Trunking is working. Let's do. I'm just about to show CDP neighbor. I don't know if CDP is running. No, we're not getting any CDP traffic across there. Okay. Try and ping 172.16.1 again. No, it's not working. Okay. Well, we see the port channel mode on each end is trunking and it's on. We do a show run, we see that it matches on each end. I'm gonna real quickly check this. Yeah, it's the interface VLAN 1, that's not a problem. Okay. Yeah, I would be suspicious in this case of packet tracer. Because I've seen. So all the configuration looks correct to me. We do a show int trunk and it shows it's carrying the VLANs. Oh, I know what. Here we've got, let's do this. I've got VLAN 2 on one side. It's carrying the same VLANs, but it's they both allow the same, but they're carrying difference. Let's do a no VLAN 2. Okay. So now the trunk, let's just see if that happened to 2.16.2. Nope, doesn't look like that, did it? Okay. It may be that little inconsistency between the switches and the VLANs and all that was causing a problem. Not sure. Let's go put those into, I'm going to try and mess around here a little bit. I'm going to go interface range FA 0/1-3. Oh, that's right. And switch port mode access. And okay. One shut down, the others went into, that's interesting. Show run, let's see if there's anything. It's got VLAN 2 is still assigned to it. See, this is sort of screwy. These commands, okay, let's go config T int FA0/1, switch port access VLAN 1. Okay. Now I'm just going to go down to PC 12 here and see what its configuration is. Does not have a default gateway, that'd be fine. FA0. Okay, so this is 12 for the desktop. And do an IP config. Confirm that. And ping 172.16.1.1. And no reply. There we go. Okay, so finally. All right, so now we have some connectivity and that's working there. So now we know that the virtual interface on the switch works. Now let's just see if we can ping across that trunk and see if that might be working. Doesn't look like that is working yet. Nope, okay. All right. So this is still not working as a port channel. As a trunk as a port channel. So let's go here. Do a show int trunk and just see if I can see anything. Whoa. No trunk. Okay. Show run. Let's see what's going on here. So the port channel is a trunk. Okay. That's interesting. But it's not trunking across there. And it might be all the messing around that we're doing with it here. Do a show run. It all looks the same on both sides. Okay. Now, that'll be another way to do a show in trunk here. So on this end, the port channel is working and it's trunking. On the other end, it is not. So we do here. And we'll just see try it again, just make sure. No trunks. So, T, replace port channel 1, switch port. Let's go access, and then put it back to a trunk. See if that. I don't think that. Nope. Okay, so what I would do in this case, I would tear this down and build it again. As I would, now that I've cleaned up the configuration as much as I think I can, I would go ahead and go config T and then go no channel 1. That's no interface. No interface. Or channel 1. Okay. And then I would go interface range. Interface 0/4-5. And I would say no channel dash group 1. I don't think we have to do any more than that. We'll just see if that, take that. Okay, then. Shut. Okay, so now they're both up as just access links. Now we go channel group. One. Mode on. And let's just see here. Let's try active on this side and here. Let's try active. And then Control Z, config T, int, port channel 1, switch port mode. Let's see if that's gonna, I don't think it did it. Nope, didn't. Okay, so I'm gonna do the same thing over here. Oh, wait, well, now just turn green. But I think it just turned green because of spanning tree on each end. I don't think it's because of it being a trunk or a port, no. Those interfaces are back up. Show run, it'll show switch port mode trunk. Okay. Let's just start this, throw this one out, interface. I'm not sure, again, whether this is, yep, interface range. The problem here is the configuration not coming together exactly right the first time, or if it was because of the packet tracer. So channel group 1. Okay, let's just do, I'm doing a do show run, just curious. So the port channel is still, okay. The interfaces now are cleaned up. I don't know about that error message you just saw. That's right. So what we want to do is channel group 1. Oh, I know what. Let's do. Let's get that interface. No, I can't do that. I have to go exit by 1 level. No int port channel 1. Let's see if that wipes that out. Okay, so now do show run. And I don't have it there. Okay, so now interface range FA04 4-5. And we want to go channel group. Well, getting a lot of practice. At least I'm getting a lot of practice with this. Channel group 1 mode. And then my options were, and I'm going to go active on this side as well. Active. Okay. And then no shut. Looks like what happened is that the other side just shut down. So I'll probably have to do no shut over there. I'm again not sure that part of this just isn't packet tracer. And then config T int port channel 1. Well, it's up. So do show int trunk. Let's just see if. Okay, says it is trunking. So switch port trunk. The show int trunk. All right. Let's do a show CDP neighbor, just see if CDP is, oh, it's working. Now it's working. Okay. So I just had to go through the exact steps on a clean configuration on each side. Ping 172.16.1.1. I don't know why it's not pinging though. It should be pinging across there. Did any mistake I made in the ping? No. Which two? 1.1. They're both in VLAN 1. VLAN 1 is the only thing across there. Well, if the let's see, hold time 173.99. Let's do it. Yeah, so CDP is working across there. Across the port channel. That's interesting. Port channel, talking to port channel, switch 1. Yeah. Well, that's some strange output there, but basically that channel is working, or CDP wouldn't be flowing across there with port channel to port channel. That tells me that we're seeing from switch 2, we're seeing switch 1 over the port channel. So, phew. That was a wrestle. Were you guys able to get it working on your end as well? Yes, no.
I couldn't do it and watch you at the same time, so I'll do it later.
Okay, so why don't, tell you what, let's take a break. We come back and then I'll have you folks configure yours. We'll take a break to 7:20. I'll have you guys configure yours and we'll make sure that everybody's got it running before we go on and see if we can also look at any troubleshooting. Okay?
Okay.
All right. So I'm going to pause the record. All right. All right. Okay, so we see our ether channel is working. I'm just going to try doing some things here. There we go. Even have ping across there. Wow, this does get pretty exciting at times. So you let me vote. You folks let me know when you have yours working, or if you have any questions you want to get to the state where it shows that it's working, and you can ping across it and run CDP across it.
Mine is working.
You got yours going, okay.
Yeah.
You're good, Armando?
Sorry, yeah, mine's working too.
Okay. And Roger, you're working fine? Roger may not be back yet. Oh, he's back. Is yours working fine too?
It's working.
Okay. Alrighty then, let's go ahead and. What am I going to? I was gonna go to, oh yeah, my next. Slide. Module. What's that? And. No, I do want 7. See, is this the one I wanted? Yes. So we have in our enterprise model that we have, though that large scenario that I sent, we have some WAN connections. And I am actually wondering, I've gone through some of these slides. Do you folks know of a chapter in which the WAN configuration is addressed? Because I was looking through these modules here and I wasn't finding it. Anybody happen to remember which chapter in the academy addresses the WAN?
I think the first section covered it a little bit, but I'm
Way
not sure.
back when, huh?
Yeah, I'm not
Yeah, that's what I thought. They just covered a little bit way back when. Okay, and I think we skipped over that. Let me take. Well, we'll go through this here and then it seems sort of strange to me that they would show you how to configure it before they tell you why and all that. But here we go. I'm gonna walk through this and then we can do the configuration and did it talk about setting the clock and so forth? Setting the DTE.
yeah, I'm pretty sure.
Okay. All right, because it's sort of interesting the way they do this. All right, so a lot of this is just discussion about why we have WANs. And you can read through some of this here and just for the most part, WAN services, we can think of that as it's going to be something that we have to pay for. And all of us are generally, in fact, we're all using WAN services right now to communicate. So something that we just sort of take for granted these days. So you can create a private WAN environment. This would be like a, it might be provided by a company within their own structure, their own infrastructure. However, most of the time that you will go through the public and through the providers. Okay. So we've got different topologies that you'll want to be familiar with. First one is your point-to-point, and we've been using in this class point-to-point topologies in those WAN links that I have created. But they make the point here, no pun intended, that having these point-to-point leased lines or dedicated lines can be very expensive. And so what people are doing much more now is some other means to get from one site to another. You might also have what's called hub and spoke topology, and understand that's this device here can communicate with that and that and that directly, but these can only communicate with each other by going first through the hub and then back out. So you have your single point of failure there. Dual homed, this is an unusual slide for dual homed, but basically all you're saying is that you've got a router that has multiple connections out to different places. So in this case, each of these is a hub and spoke topology, so you have redundancy here. Your full mesh is the most expensive, but also the most fault tolerant. You have everybody has a connection to everybody. In the military, they tend to use these through the major sites. Banks would tend to use these as well. They can't afford to not be able to communicate, so they have a lot of redundancy. Your partial mesh, we have here a hub and spoke, and between these three here, a full mesh. We have all sorts of different types of connections that we might put into use under a service level agreement. That's what an SLA would be. And we might have a single carrier connection here, SLA negotiated with just the one ISP. But if we've got a major site, we might use multiple ISPs so that we have some load balancing and also some level of redundancy and fault tolerance. For companies out there, you're going to analyze your level of need, your level of traffic, et cetera, et cetera. But for smaller companies, really, you're going to go generally with just one connection. And so in this case, we have a single LAN connected to a wireless router, and the wireless router is connected through a broadband DSL to the provider. As the company grows, then they're going to build a campus network, a CAN, and a campus network is actually what we have in our larger scenario. Those three buildings would be a campus. And so at the campus level, what you have is your access layer, then you have, and actually this would be your distribution layer, and then you have your core. And of course, each branch will generally just have a single connection into the cloud and be able to get to all of the other offices today, because often they'll just set up VPNs. Inside of a metropolitan area, when they do this, they call it a MAN. So now we have what's really happening in the world today primarily is VPNs connecting sites all over the world. And because VPNs are no more expensive to set up than the single connection to your provider, once you have your connection to your provider, then all the VPNs that you want to create, you can generally do so as long as the other end has a connection to a provider through the internet. So you've got these different organizations. You should just be familiar with those letters there, abbreviations, and also the different protocols that are used. So we've got these protocols at layer 1, physical layer, and layer 2, and just be able to identify these. We used to teach frame relay, actually, a long time ago in the CCNA. They stopped teaching it because, as you see here, it's legacy. The principles used in frame relay were good to understand, but actually it's not used very much anymore as a protocol or a provision. So when we get into our layer 2 protocols that are available to us, we're going to be using these here: Ethernet WAN, broadband wireless. MPLS is beyond the scope of this course, but MPLS is very similar to frame relay in the way that it works. Frame relay works primarily at layer 2, where MPLS, while they say it works at layer 2, it's sort of thought as between layer 2 and layer 3. PPP is used often in connections just to private homes. So you have PPP OE, PPP over Ethernet or over whatever your connection is. to your provider. That way you have authentication capabilities. So DTE, your data terminal equipment. So here we see is where your data inside of your environment terminates and where the data coming from across from your provider terminates. Your DTE is considered to be that which faces your provider. Then you have your DCE, and that is this equipment here, data communications equipment. This is everything that is used in order to move it to your provider, and actually devices inside the provider can be called DCE as well. So all of this becomes our customer premises equipment, and our basic point of presence is where our service provider actually connects to us as a subscriber. And this point where they have the connection is called the demarcation point. And sometimes that can actually be at this device here, if this is a DCE device. So if we have a CSU, DSU, we'll see that in just a second here. That would be a DCE. Some other terminology, the local loop, our central office, of course, the toll network is out here. The backhaul is in between their different devices, and the backbone is from one of these toll networks, one provider to another. Okay, so many years ago, I don't know, boy, I haven't seen a voice dial-up modem in so long, because for the most part, people don't have landlines anymore. So this would be very rare to find. DSL cable modems are often what we're using now in our private homes. These are pretty common still. And a CSU DSU is a special device. And what can be confusing about this is, what does this really stand for? What does it mean? Well, the CSU means channel service unit, and the DSU is digital service unit. So what's basically happening at a CSU DSU is you have a line coming off of your router. I'm trying to see, these are not. Well, if we had let me move this here. Yeah, there we go, CSU DSU. So I've got a line coming off my router. Think of this as a single line, generally not channelized. Okay, what do I mean by channelized? Okay, well, from here to here, you have what's called a channelized connection. And that means it's not one single stream, but it's a stream broken up into channels. And you can almost think of this as like boxcars on a train. Okay, this is each of the boxcars would be its own channel, and you can put something into each separate boxcar and into each channel. Basically, what has to happen is that the CSU DSU, is the data streams from here in a single line. When it gets here, it has to then break that up and put it into the channels that are going across here. So this is the CSU points out here. The DSU side points that way. CSU channel service unit, digital service unit. Optical converter, again, is a device that's taking information coming in here and convert it into the optical signals it needs to. Of course, we also can be connected to a wireless. Most of us are wired into our provider, but some people might actually be wirelessly connected to the provider. What's going on in here? Well, it's a cloud. The reason why we depict it as a cloud is, for the most part, unless our job is in the cloud, we don't care how it actually gets across the cloud as long as the service is acceptable. And what they use to get across the cloud can vary from provider to provider. And as the technologies evolve, it will change within the cloud. Just understand that you have a serial connection, which is what we generally are going to use connecting to our provider. And you also have the possibility of, parallel connections. So we get into some more terminology of circuits switched. Okay, a circuit switched network establishes a dedicated circuit, or it can be a dedicated channel. But if you think of it as originally the public switch telephone network, PSTN, consisted of physical wires that were connected together through switches, and the way that the switches were connected to each other was through your telephone operator. So this gets into a lot of history, and actually, for me, my grandmother was actually a telephone operator, a telephone switchboard operator, way, 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 way back, when telephones were connected by simply plugging in at the switchboard, and you would first dial up the operator. So what we used to have is a phone in which you would actually you'd crank some electricity that would send pulses down the wire and would light up at the other end where that wire came into the switch. And then the switchboard operator would see that light, would then plug in their headphones into that switch, that connection. Now the telephone operator could talk directly to the caller. So this would be a person in their home. They pick up the phone, they make this happen. The telephone operator comes on, and after some amount of gabbing, the person says, "I'd like you to connect me to," and of course, usually people were being connected to someone locally. So you might connect me over to, Betty Lou. And so the telephone operator then puts their headphones into the connection to Betty Lou, does the same thing, sends a signal out to Betty Lou that causes Betty Lou's phone to ring. Betty Lou picks it up, and the telephone operator says, "I've got a call coming in from Mrs. Smith. She wants to talk to you." That's great. After some gabbing, she takes a wire and she puts one end into the connection from Mrs. Smith. The other end goes into the connection to Betty Lou. And now the two of them have a dedicated wire on their conversation. And then if you want to go to someplace that's not local, you tell the operator, and then they connect you to the next local office or central office, whatever it's going to be. And you simply pass this along until you get a complete wired connection all the way through from one end to the other. Well, there used to be primarily female operators, and the reason for that was, from what I understand, is that the women tended to be nicer to the customers, so everybody preferred to talk to a female operator than a male, so the telephone company primarily hired female operators. There was some problem in one little city, though, one town, where people would call in. This is anecdotal, but the people would call in if they needed to talk to the mortuary. And there were two mortuaries in town, And one of the telephone operators was related to one of the mortuaries. So she would always switch someone over to the mortuary that was run by her relative, and that upset the other guy. And so he built a switch, and that was a switch that's automatic. And that's when we get into dial phones. And what the dial phone would do is, as you turn the dial on the rotary dial, and you released it, it would send pulses down the wire, and those pulses would cause little switches inside the larger switch to then rotate a certain amount and form connections. And then as you dialed a number, you would build connections all the way through to your other end. So it was an automatic switch rather than the personal people that were involved at the switchboard operator. And that worked pretty well. Very noisy, supposedly, inside of a central office with those switches in operation. But that was, why we had rotary phones with rotary dials. And that's also how we got to area codes and what they are. So if you ever looked at a rotary dial, and probably most of you haven't, but if you ever did, you would see it starts at 1 on the is the shortest throw, and then it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. So when you want to dial a remote location, what all of the area codes would have in them originally was the middle digit would be a 0 or a 1. And so when they came up with area codes, what they did is they assigned the lowest throw on the dial to the area codes that were used the most. So that's why New York is 212. That's the shortest throw, or the least amount of spinning you have to do of that rotary dial. Los Angeles is 213, so just a little bit more. And as you go through, you see that San Francisco is 415, et cetera, et cetera. Well, when we went to cell phones and all that, eventually the whole thing with the middle number being a 1 or a 0 was tossed out, and now area codes can be whatever they want, doesn't matter anymore. But that's how area codes were originally created and assigned, was based upon what was the easiest to dial versus what was the most used area codes. So those methods establish an actual circuit from one end to another. So it's called a circuit switched network. Now, when we get to ISDN, what ISDN does, instead of having a physical switch here that then builds a connection to that, and then again a connection to that, what ISDN does is, with a out of band communication, meaning not in this band here. By the way, in band is an in band circuit establishment is using the actual data band. ISDN uses a different band to communicate between these two switches, and they communicate and set up a circuit between them. And when you get done, you had this circuit from one end to another. But again, a circuit switched environment. Now, packet switched is sort of like routing, is really what it comes down to. But it can be at layer 2 or layer 3. If it's layer 2, then it's done more on the actual either label or frame relay. Basically had a circuit identifier. MPLS uses labels, and essentially what happens is these two devices, if it's an MPLS, they establish between themselves what a given label means for moving the packet forward. So for example, we're again going to make it very simple. Let's say in this case, we have only two possible directions that this switch can send things. If it was using MPLS, then it would tell this person for all connections, and it would give them, basically going out there. It wouldn't say that going out there. It would say, for these connections, use a label A, and for these connections, use a label B. And it essentially just sets that up in a table. And now over here, when a router gets something and it's using MPLS, it simply adds an MPLS header and label on and says, okay, if I tell this guy A, that means it's going to get out that way. If I tell B, it's going to go out that way. So it's going to label it A or B. This makes it extremely fast here because now it doesn't have to look into a routing table to determine where things are going. It simply has to say, is it A or is it B? Bingo, that's how fast it is. So that's why MPLS has become more popular. It's faster. You can set up these labels in advance, so you have something that's really an established labeled circuit. And because the label is what they're using to determine where it goes next, it doesn't matter what protocol you're carrying inside of this packet. You put the label in front, this switch here never looks at what is actually being carried. So it can carry any protocol that you want to put into it. And these are your layer one standards. You just want to be familiar with those for the test. What you'll end up using out there in the your provider or your company will depend on what they can afford and what they need. So here are some options that you might come across out there. So if we establish a leased line, again, T1 or T3 in North America, E1, E3 in Europe, if we establish a dedicated leased line, conceptually, it's very similar to if, let's say you had a phone, so everybody has a phone, but let's say you bought a phone and a friend of yours bought a phone. And what you did is you dialed each other, or you dialed the other person, and you established a call between the two of you, and you didn't hang up, and you just set the phone on the counter, did not hang up, okay? Now, at that point, anytime you want to talk to your friend at the other end, you just talk into the phone. You never have to dial. So you just might say there's no dial tone, there's never a dial up, a dedicated lease line is always there. And of course, if you have to buy a phone for each of your friends, that gets expensive. And the same thing when you're buying leased lines to different locations for companies, a lease line is the most expensive option. It's basically you have dedicated a line from you to the other, and if you use it 0 or you use it 100%, it doesn't matter. It is the same price. Now, you have a switched possibility, and we talked about circuit switched and packet switched already. So essentially, this is how we build our connection to the other side. T carrier in North America and E in Europe. Now note a T1 link can be up to 1.544. For the most part, when you go to configure a serial interface on the Cisco routers, most of them default to the speed being 1.544. As far as the bandwidth assigned for reference purposes. The actual speed of any link on a serial interface is set by the clocking. That's the actual speed. So what you see in a device, and I don't have, let's see, I don't have one handy. Oh, let's see, do I? Just a second here. Maybe I know if I have no, I don't have a serial interface on that one. Maybe I can pull one up here. Da, da, da. How come? Here we go. And let's just see if I've got one that 1941. One non-modular one is what I want. No, I think 2620. Let me just see here if this one. Oh, there it is. I just want to see if it has a serial. I can show you what I mean by the bandwidth. But actually, it doesn't have to be that. The end. Show run. Let's just see what it has on it. It just has gigabit. Okay. So we'll just do this just so you can see it. Interface gigabit 0/0. No, I'm sorry. Exit. Want that. Show int gigabit 0/0. Let's hit this though. I need to be back one more level. Yeah. Show int I 0/0. Okay. Here we go. Right here, BW stands for the speed or bandwidth, actually, of the interface. Now, for a gigabit interface, the speed is built into the interface. And so we can say that that is the speed, and we can assign a bandwidth value of that for reference purposes. On a serial interface, the bandwidth that will be assigned generally will be the 1.544 number, but the speed of the interface itself is not determined by that. What determines the speed of the interface is the clock rate, just so you know. So if we look at these, point-to-point communication links are pretty easy. Obviously, they have all of the bandwidth available to the user, and they're always available. Okay, they generally doesn't matter what you're running over them. Okay, and the cost and flexibility is a problem. So they are going to be hardwired from one end to the other. So if you want to move an office, you have to take that down and put in something else or reconnect it through a different provider. Okay, these are PTSN, talked about those. And frame relay, these are basically legacy. And if you ever come across these, if you're trying to configure OSPF, then you need to know that this is non-broadcast multi-access. That will become important there. And if you're ever configuring frame relay, you're setting up what are called data link connection identifiers or DLCs. We saw some of this before, but basically we're looking at the different types of connections that we might have to get to the internet. Folks are familiar with those. Okay. So I think we've already seen it. Well, now we have internet-based added to our drawing up here, and we can see the different options there. And yes, packet switched applies to MPLS. And again, whether it's layer 2 or layer 3, people differ on their characterization of that. And what we're trying to provide often is a VPLS, Virtual Private LAN Service. And what that gives us is the capability of a connection that only we use. However, in the sense that we are the only ones that are sending traffic from one end to the other over this virtual private LAN. And it's virtual, I should say it's virtually private because we encrypt across it. And this is MPLS, talked about this earlier. Basically, yes, you have an MPLS cloud. However you get there, it really doesn't matter. But once you get into the cloud, each of these routers is using a label to determine where it forwards the packet next. I think this is going to be pretty much everything we've talked about and what you folks would know already. Okay, there's that. I don't really need to talk about that. Yeah, so I don't know that I can really, yeah, you'd want to know this for test purposes, asymmetric or symmetric. Okay, and it's just the difference in the upstream and downstream speeds. Okay. And a DSLAM basically is a DSL access multiplexer. And a multiplexer is basically a device that takes multiple inputs and can move them across a single wire. And at the other end, you can take all these inputs and move them back out to various locations. Now, everybody would understand the concept of a multiplexer if you just imagine if you have a TV, you have a cable coming into your house, and on that cable are multiple channels. There's a ton of different channels coming into your house on the single cable. Now, your device in your house is a multiplexer. And when you use the remote, you go from one channel to the next, you're just selecting one of the different channels that is being carried through that cable. All the channels are being carried at the same time. When you go from one channel to the next, you are not establishing a different connection to your provider. You're just selecting a different channel within the stream of data that's coming to you. So inside your house, you have a multiplexer. Now, point-to-point protocol, because PPP carries within it the capability of authentication, it's often used like PPP over Ethernet. And that allows, before you actually connect to your provider over Ethernet, you authenticate in some way, shape, or form. And this is done so that when you hook up your equipment inside your house, they know who they're hooking up to, and then they know who to bill and how much. Whether it comes in over cable or Ethernet really is not critical. And some people now have fiber, actually. I'm not sure, but fiber may be an option in mine. I think fiber is now an option in my own neighborhood. I don't have it, but some people do. And I guess once you get fiber, the speeds jump way up. And these are things that we pretty much come across, municipal Wi-Fi, yes, cellular, et cetera, et cetera. So I don't think there's much I can add to most of these coming down. In fact, we're pretty much at the and yeah, so you'd want to know these terms right here, and they're explained: single homed, dual homed, multi-homed, and dual multi-home. Very easily understood. Okay. And again, just review this before the test so that you're familiar with these terms. Try and keep them straight. All right, that takes us to that. I was going to bring up one more thing on this side. LLDP. I want to just go over this a little bit. So earlier you saw me use the command show CDP neighbors. Well, CDP is a Cisco discovery protocol, and it's Cisco proprietary. And the problem is that Cisco isn't the only company making devices, routers, switches, etc. And so you may want to use a non-proprietary protocol for discovering neighboring devices, even though you're on a Cisco device. If it's talking to a non-Cisco device, CDP won't work. So there is something called LLDP, and this basically works like CDP at layer 2. So you have advertisements that are being sent back and forth. Okay. And you have these commands. So globally, you can say LLDP run. And then on an interface, you can say, do you transmit or receive? And then show LLDP to determine what the configuration looks like. And just like I did show CDP neighbors, show LLDP neighbors, and you'll get information about your neighbors. And one thing that they love to try and trick you on, they'll show you a diagram, and you need to know that local interface is yours and the port ID is theirs. You also need to know, of course, what this means. Of course, you've got a little table reference index right there, but they love to try and mix you up as far as in questions as to whether the information coming in is coming in from the other side's gigabit or your own FA or something like that. So just make sure you keep that straight. That's what I found is the the way they try and trick you on the questions primarily. Okay. And then show LLDP neighbors detail, just like show CDP neighbors detail. Same basic concept. Okay. Again, for test purposes, the network time protocol, and this is one that's fairly easy to configure. You just want to understand the terminology that's being used. So you can set the clock on your router, but that is very, shall we say, not unscalable. It's you're not going to get consistent time from all of your different devices because you can't set them all at the same time and It's just a pain. You wouldn't want to do this. What you want is to have all the devices have exactly the same time, and you want them to get that time from some central time source. Now, why do you care? The reason why you care is primarily what's going to happen is that you're going to at some point do logging or have some error messages or things like that. And when those messages are generated, whatever protocol might be used or however they might be generated, they're going to have a timestamp. And with that timestamp, you then can do the troubleshooting that you need to do. And especially if you're reviewing logs, you're going to need that timestamp to know if an error message or a particular, flow of packets, pings, whatever, if they are correlated with some other packets that are happening out there at the network at the same time. And this also relates to forensics. So one possible area that you can get into in the world of IT is IT forensics. If you're an administrator, you are, in a sense, already involved with IT forensics, whether you like it or not. And what that means is that everything that happens on a network could possibly, at some point down the road, become information that is going to be introduced into a legal proceeding. Could be a criminal or it could be a civil proceeding. And it could be, non-criminal. There may be agencies that, would be coming down on you. I was once working in a company and all of a sudden we got a message, do not delete anything off your hard drive. And basically what was happening is one of the governing agencies had, what really happened is an unhappy employee, when they were let go, told on us, the company, I should say, not me, but the company. And they said that we were illegally installing software on machines without having a license for each installation. Well, this was a company that was selling software. And so we had software from the different, vendors out there. And yes, we would install Microsoft Word on a bunch of different computers out there. And in the training center, we would install it and so forth, without a license for each installation. So that's why the governing body was basically triggered and was going to investigate. However, because we're selling software, what happened was the company contacted the vendors and they called up Microsoft and they called up, Norton and whatever, NetWare, whatever, all the companies whose software we were selling. And they said, we're being investigated because we keep installing your software on our local machines here, so will you please just give us basically a license to install whatever amount we need, an open-end license, because that's how we demonstrate your software. And of course, we use it inside here in our company as well. And so all the companies said, sure, and it went away very quickly. However, if we had not been in that business, but had been just a regular business installing, one copy of software on all our machines, we would have been in violation of the license agreement. And that can carry some fairly heavy penalties. And I was once sent out as a consultant by this software company that I was working for, sent out as a consultant to a small business, and they wanted to install 20 different machines as one piece of software. And they wanted me to come out and install one and just, use the same one and copy it. They buy one, say install it on all our machines. And I said, well, I can't do that. I can only install it on one machine. You can watch me install it. What you do with it after that is up to you. However, I will have to send you a letter and say, if you install it on multiple machines, you'll be in violation of the license. And that was a CYA move on my part. And that's what happened. I went out, I showed them, here's how you install it on this one machine. Thank you very much. I'm out of here. And of course, don't install it without a license. And they did whatever they wanted to do. That was the last of that. However, So the time that is being sent to your logs is important both internally, can be important for security to follow up on security breaches, could end up being introduced into a legal proceeding as well. So one thing that a friend of mine said not too long ago, talking about the world of IT versus the world of law, and sort of saying, well, you know, if you're practicing law, you can really hurt somebody if you practice the law and you don't do it well. And that is true. You can cause somebody an awful lot of grief if you, engage in malpractice in law. You can also cause a tremendous amount of grief to somebody or a company through IT. And you probably would, if you thought about this for more than a moment, you'd realize that if you are the IT administrator, essentially all the productivity within your company is being achieved by way of people using computers. And if the network goes down, then suddenly the company is non-productive, and devices that go down can cost the company huge amounts of money. There was many, many years ago when NetWare was the primary server software that was used in LANs. NetWare came out with a piece of software that would run on a server, a NetWare server. And all it did was synchronize one server with another so that if one server went down, the other server could take over in real time. In other words, the two were running alongside each other in sync in all respects. It wasn't just a matter of a backup. It was a real-time failover, and it was achieved by way of this software. And the software cost $15,000, which back then struck me as quite a bit. But as soon as you think about how much it might cost a company to have their server go down, for example, a company that's making sales off their server, $15,000 can be pretty inexpensive. So your job as an IT administrator is to assess all of these different vulnerabilities of your network and what it would cost if there were any failures or breaches, etc., and then make a risk-benefit analysis as to how you go about protecting your network, because ultimately, what you're really doing as the IT, if you're involved with IT, is you are protecting the business. And I always encourage the students in my class that we're going to get out into the field, think of yourself as someone who is keeping the business running. And if you fail at your job, that business could come down. And I came across this anecdotal piece of evidence or information that said that companies that lost access to their data for more than 3 days, they had done this survey, and any company that, of companies that lost access to their data more than 3 days in a row, some huge percentage of them, like 80, 90% of them went out of business within 6 months. So that's how vulnerable a business is. And I was once asked to come in and can do some tinker with a guy. A guy was he was a consultant for this company, and he wanted me to come in and help him with a Microsoft server. And I was like, gee, I don't want to touch someone else's network, especially not where I'm not fully aware of everything that's going on. So he wasn't too happy with me that I wouldn't, just automatically run over and start tinkering with their network to see what he might be able to do to it. And he wasn't trying to do something harmful, but to me, you can so easily bring the network down. And another anecdote along those lines, we looked at VTP a while back. I don't know if you folks remember, I may have shared this already, but I did have a guy in my class because his company went down, their network went down for like a day and a half because of VTP. But there was also a better story. And did I tell you about the Air Force, the US Air Force in Britain, when their stations in Britain, it was either US, it may have been the British, but I think it was the US Air Force in Britain. Their entire network went down because of somebody mismanaging VTP. And it went down for like 2 days. And I had to sort of laugh ironically. I said, well, VTB was able to bring down England in for 2 days. Hitler was not able to do it after, dropping bombs for a month. But anyway, it's pretty fascinating what you can do. And it's also pretty scary. There's a tremendous amount of responsibility when you are a network administrator. And so back to NTP, you want to make sure that every device in your network has the correct time. And the way you can do that is with NTP as a protocol. And note UDP port that it's using. Okay. And you can have it set up to a local private master, or it can go to a public NTP server on the internet. And you want to be familiar with these right here, what's going on. So you have a master out there. Let's say this master is on the internet. What you want is to have all of these devices and all the devices that are connected to them, all of them to have the same time. And we want to get that time from here. But we don't want all of our devices contacting that one central device. So what happens is we create this hierarchical structure or stratum. And we have this one at stratum 1, it's going to get its time directly. These are going to get their time from that, and so forth. And so what you're trying to do then is establish this hierarchical structure. And down here, you might have all of your workstations and so forth, and they're getting time from something down here. This just makes things much more straightforward to configure. Okay, so you want to know this information here, the different stratum levels. And here's how this is really all we have to do. That right there, we say NTP server, and that's the IP address that this device is going to get its time from. Do a show clock detail. We're getting our clock from local configuration. We do that. Now we're getting it from NTP. You should know what's going on here. It's a little bit weird the way they've got this set up, but show NTP associations. Okay, so we're getting our time from this peer right there. That's the reference clock, stratum level, WAN pole, etc. So become familiar with this, and because it's very often that they'll toss an NTP question on the CCNA exam, and it will give you this as part of the question. Okay, and here we go again. So you should be able to answer questions from this information. Let's see if we, I think we have time. We can go through SNMP next. Again, out there in the real world, you may use this, and it's Simple Network Management Protocol is what it stands for. And it is simple. We'll see why it's supposed to be considered simple, or why they talk about it. Okay. So we have these 3 elements. The SNMP manager, that will be you at a workstation trying to manage some other device. And on that other device, there will be a piece of software running. It's called the SNMP agent. So a good way to think of this so that you understand what's going on. SNMP Manager is a piece of software that lets you ask questions of the SNMP agent, which is a piece of software running on the managed device or node, and it will give you back answers. So you, as the manager, you can say, what is the status of this port? Say that port is up and running, and the way that the SNMP agent knows that the port is up and running is because the SNMP agent looks into what's called the MIB, the Management Information Base. And this is basically a database. It's a hierarchical database. And what you actually put together up here as a manager is a question to the agent that says, get me this information out of the management information base. That's really what happens. And that's why it's called simple, because the SNMP manager, one of the few things it does, it says, get me this information. And you have to describe that information. And the agent gets that information for you and sends it back. Okay. Now, I just showed you, get is one of the things that you can do. Get me information. Another thing that you can do is say set. So with the set command, I can say to a particular device, for example, I could say set interface FA0/0 to down. Oh, you just shut down an interface from over here. You just shut down an interface here. Okay, you did that very simply. You said set, and then you describe that interface in the right language, and that gets a little bit, involved, but basically you would be able to tell it, shut down interface FA0/0. If you have authenticated properly, this device will shut down that interface. Now, there was a time when SNMP was a huge vulnerability for Cisco devices. And here's what the SNMP manager could do. It would say, get me the configuration for this device. Oh, okay. The agent, SNMP agent, after you've authenticated, gives you the configuration. Now what you do is you modify the configuration however you want, and you say set the configuration to, and you send it back the modified configuration, and you have now done whatever you want to do on that device. Huge, huge security vulnerability. Of course, that's been addressed, but that was at one time how simple it could be if you knew the right way to get into this. Get me the configuration and then set the configuration to this, or, get me the status of this interface and set it to down, whatever. All right. So get and set, and this is why they call it the simple network management protocol, because so far we're very simply saying, get me this or set me. Anybody can, there's just two commands that you are issuing. Now, you can also have the agent send out information when something happens, and we call that a trap. And so what you can say over here is, if this interface, over here, if FA0/0 goes down, send me a notification to here, and that would be called sending a trap to the SNMP manager. So now we have three things in our simple network management protocol. Okay. So we have a little addition here but they're just a variation of the same thing. A get request, which we've just been describing. Oh, a get next, which just means in the database, walk down, one more level or go to this next variable, or get bulk request, just get me a bunch of stuff. So these are all the same thing. They're all get commands. Okay. A get response is just what they give us back. And then a set request is, as I said, change. So you can see it's not complicated as to what you're doing. Get, okay, here's what you just asked for, and then set. So when we say get, we're actually talking about information in the MIB, management information base, but just a database. It's a hierarchical database, but it's a database. Set something in the database. Trap is just a message coming from the manager software. I'm sorry, the agent software going to the manager software. Just an alert or a notification. You'll want to know the different versions and the different authentication, because one of the problems was whether, to what extent there was good authentication. And originally it used what's called a community string. Okay, community string is a fancy word for a password. Okay, and anyway, whereas authentication would have username, password, encryption, all this different stuff going here. So with our community strings, again, for test purposes, because you'll probably use something more complicated, more secure than this, a read-only community string, in other words, the password that was the read-only password, let you view things, but the read-write let you change things. That's it, simple as it was. So community string that was a read-only community string, just let you see things. Now the MIB object ID, this is where we like to get into making things far from intuitive, shall we say, until we actually understand it, but certainly not real easy to use. Okay, in the sense of, it's not English, and we'll see right here. Okay, so the way that we describe an object, and I said this is a hierarchical database, and this is the hierarchy right there. And every, MIBs have different hierarchies depending upon what we see right here. Under enterprises, there is a MIB option for the Cisco enterprise. So if I wanted to look at what's going on with the Cisco, something in Cisco, I have to walk the agent down through this hierarchical structure. And I have to go from ISO, go to organization, to DoD, to internet, private, enterprises, Cisco. Well, each of these has a number assigned to it. And we just put that together, 1.3.6.1.4.1.9. That describes the object that's right here. It's called the Cisco enterprise object. Now we're actually going to go down. That's not going to get us much. We're going to go down, and inside of each object, we'll find different variables that we're going to want to get. But when I issue a get command, one way to issue a get command, of course, there's GUIs that make this easier. But one way to issue a get command is get, and then you just put this long string in there if you've got it right, and you've got the correct community string, then the response will give you the variable that goes with that object ID. Bingo. Couldn't be easier, right? Well, I guess it could be. Okay, so you can get information this way, and there's a polling scenario. You're just trying to see, well, what's going on with the CPU usage? Da, 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 da. Okay. And SNMP get gives you insight into how it works. And essentially you've got some variable and you keep issuing that. And in this case, we have a GUI that lets you do this much more easily. Okay. So I think I'm going to stop there for tonight, and we'll pick up with syslog the next time, talk about that, give you a chance to absorb this. We'll go on to syslog and then go on to some other aspects of networking that we're going to want to cover. I believe this is the last night, though, for the second class. Does anybody else have confirmation of that? I'd have to go back and look at the calendar, but I think this is the last night of class 2.
That's what we said last week, that this is the last class.
Yes. Yeah, this is the last week of this class. So now we're in class 3. Now, of course, we don't care if it's class 1, 2, or 3 in the sense of we're just moving along. However, I am going to go through some more slides, and we'll find some more topics that we want to cover. But what I want to shift to is our scenario, that campus or that enterprise-wide scenario. And we're going to essentially, with a not unconfigured scenario, we're going to bring the whole thing up to operation using all of these different tools that we've covered in the SNMP. So we'll end up with how we set up DHCP, HSRP. We'll set, I think NTP is supported by Packet Tracer. Let's see, we're going to set up, STP. We can set up Ether channel, OSPF, static routes, etc. We'll just also a NAT at the base. We've done all these things, but now we're going to bring it all together as sort of one big configuration project, so that when we get done, everything in that scenario is running. You have connectivity from every place to every place, and you have all of these different utilities in use, running, and you have telnet capability. We can also set up SSH capability. Trying to think what else that we'll want to have in there. Then we'll have all the security set up, passwords. We'll try and set up, I think it supports a central password, so that we can actually not have to configure every single device with its password, but we can set up users and passwords in a single central database, and so forth. So that will be where we're shifting to from here on out, with some more slides to pick up some of the chapters that we missed. Okay. All right. So yeah, thank you. Hope you guys have a good weekend. It looks like the rain is going to stop and good weather is on its way, it looks like. I don't know if I'd believe that, but so far it looks like good weather's on its way. So should be fun. All
Thank
right.
you.
Thank you.
All right. Have a good night.
You too.
Good night.
Good night.